Exactly.
Just a recipe for dessert.
Absolutely.
I thought when I pushed the draft up, I actually saved you. So that's why.
Sorry.
So, yeah. I'm sure this is exactly, I know you see this. Yeah. Mark. Yeah, but they bring it. Hey, how you doing? Yes. Yes. Yep. Yeah. Push it out.
It says for full screen.
They wanted me to go, and I'm like, maybe I'd rather.
I have no idea. It's this into presentation mode. There it is.
Beautiful. Don't touch anything.
Okay, we're going to get started. Can somebody close the door in the back? Welcome to Lamps. So we asked for a 1 hour slot because we had just a few presentations and many of our documents were with the ISG. And then along came a whole bunch of requests after we had only a 1 hour slot for requests for additional work. So we're going to keep a quick pace in the hopes to get through them all. But if we don't get to the last ones, I added them in a kind of first come, first serve basis. And so we'll do what we can to keep time. That said, this is an IETF meeting. Note well applies. By this time, you've seen this slide a lot in your various meetings, but please, these are the rules about the standards process and conduct, code of conduct, and IPR disclosures. So we recently completed 2 SYM documents, sort of. They're in R48, so we know what their RC numbers are, but we don't, they're not yet. We haven't actually seen the official publication announcement yet. So this is the agenda for today. The first slug of these will be very, very short. In fact, many of them don't even have slides, but we want to make sure that if somebody has an issue, they have an opportunity to raise it. And then we'll move to the active working group documents, of which there's 1. And then, I forgot to update this slide. We do have a presentation, then 2 presentations on header protection, and then a whole bunch of other business. The reason I put the header protection ones first is we have a recharter before the ISG for that work. That is not yet approved, but we're waiting to hear on that. Okay, so that's it for the chair slides. Any questions about them? Okay. So in terms of the agenda, the first one is the CAA document, which is with the ISG. I'm going to let Tim take care of that one.
All right. Do we have slides for this one?
Oh, okay. You know what? We don't need minute taker.
Oh, right. Okay. Minute taker. Who's going to be the minute taker for this meeting?
Thank you.
All right. Thank you.
I'm Do we have a Jabber Scribe?
Jabber scribe. Rich, thank you.
And the blue sheets are going around.
All right. All right, so back to my original question.
Yep.
Do we have slides for this one?
We have no slides.
No slides for this one. All right, so this one has been submitted to the ISG. I'm not aware of any open issues with it. So unless somebody has something to bring up on this particular item, we'll move on to the next one. All right, thanks everyone.
All right, the next one is the hash of root key cert extension that went through a fairly long last call, came back to the working group to sort some issues. They were sorted. There's a couple things that were declared in the rough, but then it was sent back to the ISG. So I believe IETF last call is over, but IESG evaluation is not yet finished. But they have not sent any issues back to us, so there's nothing to talk about. The next two are the shake documents, PKIX and CMS. Quinn, do you want to give us a status, or Panos? They in the room? Okay, well, I don't see them. We're in the same situation with them. They're with the ISG. We have not received any comments yet, so nothing to do until they do. The next one is hash-based digital signatures. That one was just sent to the ISG. I have some slides posted. I'm just going to jump to the end because we have so many other presentations. I want to just do the status slide. Small corrections were made to align with the McGrew hash SIGs document, which is now in auth 48. We'll get a RC number momentarily. The last issue that was sorted was how to deal with the two situations in CMS when there's signed attributes and there's not signed attributes. That was the last discussion on the list. Thanks, Jim, for that one. He pushed really hard for the same approach being used across different places. And anyway, that was the winning argument. So we completed last call, and it's been sent to the ISG. We have not yet heard of security AD review being done. That's where that is. So no issues to talk about that I'm aware of. Anyone have any? Okay. So I'll move to the presenter's mic for this. Okay, Russ Housley. This is how to use pre-shared keys with the cryptographic message syntax. It's the working group's only active document that is in Charter. That's weird.
Yeah, I'll handle the slides.
All right, the first is why would you want to mix a PSK with other key management techniques? The answer is for quantum protection. This is a short-term solution. The long-term solution is quantum-resistant public key crypto algorithms. There's a whole NIST competition going on regarding that. Not trying to usurp it, just trying to have something for now. Next. So basically what you do is you mix a PSK with a key that comes from one of the other approaches, key transport, meaning an RSA-like algorithm. So you mix a PSK with the key that's distributed under RSA, and key agreement, a Diffie-Hellman-like scheme. So the resulting shared secret gets mixed with the PSK to produce the resulting key. So there's a mechanism defined for each of those in the draft. Next. This is slides unchanged from last time. It just explains the two approaches, which I just summarized. This is more detail. Next. So, summary of the recent changes. The way that the key agreement was described talked about a key derivation key, but when you actually looked back at the other CMS documentations, it talked about producing a key exchange key. So to align the terminology with the things that are already RFCs, we talk about using the key agreement scheme to produce KEK1, mixing it with the PSK to produce KEK2. It's just so that the terminology lines up across documents. Once we have, so to do that, a key derivation function is used. And so we defined this one called the CMS ORI for PSK other info. Okay. And basically that is the other info used as part of the key derivation input. And that is the place where we're putting the PSK. In the previous version, we were concatenating the shared secret and the PSK. This basically provides, if you go read about HKDF and some of the other structures, they talk about other private info as one of the inputs to the PSK, and that seemed to be the place to put it, just from a aligning with the terminology section. So that was the change that was made. And then we added examples to Appendix A and Appendix B. One does a key trans example and one does a key agreement example. Next slide. So I'm calling for review. I think the draft is now ready for working group last call, now that it's got examples in it. But I'd love for someone to check the examples, because they're just a Python script that I threw together to slam it all together. I found some Python ASN1 libraries. And anyway, please send comments to the list. Since I'm author of this document, Tim will make all of the consensus calls related to it. And does anybody have any issues they know about, or should we begin working group last call soon? Yeah, this poll in the middle. Okay, seeing no hands, Tim, please start working group last call on this.
I will. All right, thank you. I'm also going to try to find time to look at your examples, but no promises.
Please do.
Yeah.
Okay, where's Alexis? Bernie, you want to do both of them? Well, you want to do yours or his? Which one do you want to do? Start with yours?
Optional if Alexi likes to do his own.
Okay, then we'll do yours.
Okay.
Still not doing something. Okay.
From the full screen is fun.
I did. I don't know what, but I did.
Okay. Mein Name ist Bernie Hünneisen. And In the function, I speak for the PEP Foundation, who's working on header protection in a slightly different way than in S-MIME, but yeah, I'll come to that. Next slide. So Claudio, who's sitting over there, and myself wrote a draft on the topic header protection that contains some generic use cases and a first set of requirements to base discussion on. And then there is some implementation report on the topic, mostly describing how the PEP implementation is doing the header protection, which is pretty similar than what's in the S-MIME, but I'll come to that later. Next slide, please. So the background for this presentation is that we have a pending recharter with adding this charter item for adding a topic to encrypt or signature of headers. I'm not going to the details of this. Next slide, please. So I thought a picture says more than 1,000 words. So basically what we have in general is the left side. We have a header and we have a content. The content can be protected easily, but the header cannot be protected as such. What S-MIME proposes since version 3.1 is to put the whole message and wrap it into a new mail message so that you can protect also the header part. It gives slight instructions on what you put to the outer header, but it's kind of lacking also some stuff. And the bigger problem is that the implementation of this mechanism is not so wide. There is one for sure and a couple of other implementations that may have implemented in S-MIME. And if you go to the next slide, please. There is the PEP implementation. It doesn't do it for S-MIME yet, but is planning to do it for S-MIME, but has done it for PGP in this way. It's pretty similar, except for the message, we also include the public key to the header protection. So it's a multi-part MIME structure that is first having the header and the content of the original message in one part, and then the public key in another part. Next, please. So now it's a slide that also requires kind of feedback from the stage or from the floor. Basically, which protection level use cases are in scope? So we have for sure signature and encryption is a use case. There is probably also a use case for signature only. What is a bit unclear if we need to address the use case encryption only also, or whether we can just like consider this as the same as the first one, like signature and encryption, or whether this needs to be separate, or we can leave that completely out. Are there any comments from you guys? No? Oh, yeah, I'm just pretty sure yes.
This is Daniel Kahn-Gilmore from the ACLU. I think we need to say something specifically about C, just because it's going to happen. I do think that there are user interface concerns that come up when you have encrypted headers in an encrypted message that doesn't have a signature. So I do think that we're going to need to deal with C one way or the other. I don't like it. It's kind of annoying that we have this messiness, but that's the, we're inheriting, this is the problem. This is the curse of the deployed base, right? That's what we're struggling with. So I think we have to deal with it. So I'd love to drop it, but I do think it's distinct from A.
I understand why you don't like the C, but what if we treat C as a very plain email, right? So there's no authentication there, just a protection for the data, but why that bothers you?
Sorry, do you want to say anything?
No. Yeah. Max Palacable Labs.
So this is DKG again. So sorry, if we decide that what we want to say is user agents receiving a message like this should not display any sort of security indicators, that's fine, but we still need to say something, right? That's what I'm saying. Like the use case needs to be addressed.
From my point of view, Max Bala, Cableland, I would like to keep it and make sure that you guys don't assume this is a secure email. This is not a secure email. It's just a protection mechanism for the data. That's it.
So let me just be clear. One of the things I really like about this draft is that it calls out these specific cases and says we need to make sure that we are addressing each of them. And it feels tedious. It feels like it makes me tired thinking about all the cases, but we have to do it. And so one of the things that I really like about this draft is that it's very explicit and says, here's the things that we have to make sure that we cover in order to do this stuff. And while I would like to have fewer things to cover, I think we have to do it.
Okay, thanks. So I don't think there's so much discussion on this. It's basically which interaction cases we need to support. Like certainly if both clients support the new header protection mechanisms, but we also need to probably support that if a client who supports that new mechanism is talking to a client who doesn't know anything about header protection. We probably also have to say something about the other thing. If email comes in from an unaware client to one who supports it. And the last one is just for the sake of completeness, unaware client sending an email to unaware. We probably need to look at it, document some small things, but I think we can mostly leave it out. Next slide. This is probably causing more discussions, like how well do we deal with the legacy stuff? I heard different statements, like we should leave the legacy completely out. Probably we can't do that. We probably have to deal with what's already in the standard since ESMA 3.1. And we also probably need to think when we extend this to the PGP world about other implementations. But again, I would like to have some feedback from the floor, if there is any.
DKG again. We do need to think about what these interaction cases are. And so again, like this is the same comment that I made before, but like this is tedious and this is what we signed up for when we deal with encrypted email. So I really do appreciate that we have this list of the different cases. I'm not sure, maybe there's a way that we can coalesce some of them, but I do think that we need to be thinking, we need to at least explicitly say, here's what happens with legacy clients. And here's what we expect to be done. And if the answer is we can't figure out how to fix them, then that interaction, then that's fine, but we need to call that out in the draft and say, this is something that we don't, like, these people will be sad in this interaction, and here's why.
Okay. Any further comments, Alexei?
Yeah, just very much in line with this. If we know of annoying side effects in major clients, which are legacy, then, and depending on the course we decide, then it's better if we can document at least and say, you might observe this in the wild, this is the sort of behavior, and we might or might not have a recommendation. We'll see.
Okay, thanks. So I tried to find all the requirements you need to think at. That doesn't mean that you really need to address them, but it's probably a list. It's basically a list that contains what we should think at. What I expect from the discussion here is that if there is something missing, we need to consider it, that you let me know, or you will let the room know that we need to consider it as well. We probably don't have time to go into the requirements, whether or not they make sense, whether they should be changed or so. We probably don't have the time today to discuss about that. But for me, it would be most helpful if I know if I missed something or if we missed something. So I split it in general requirements, sender side and receiver side requirements. In general, we need to specify the format we are going to use, the MIME structure, content type, and so on. What is from our side, we need to think about transport of public keys, which is probably not in everybody's focus. It should be easily implementable, and we should think about the mitigation of man-in-the-middle attacks, or in particular, downgrade attacks. And the B1 means backwards compatibility to the to clients knowing nothing about header protection. This will be in the next presentation from Alexei. We explained that we need probably to find a means to distinguish between a forwarded message or just a wrapped message for encryption. Next, please. Then the sender requirements is, in the signature case, we need to define which header fields we should protect. In the encryption case, we need to figure out which header fields need to be left in clear, but we also need to think about what should be not in clear, sent over the wire. And there's also like a requirement which header fields we should not include in any header protection part. For example, the BCC would be a bad idea to include that to a header protected field, because that's probably not meant for the final destination. Then in the draft, I also discussed a bit about some kind of a feature negotiation mechanism. Not sure we need that or not, but probably we should be able to tell we support this new header protection, just do it according to the new one. And also we should probably think about how the subject header field can be displayed to header protection unaware clients. So if we do something with the message and the receiver needs to figure out where is the subject. So what we need also to think about that. Receiver requirements is next slide. We need to think about if there's conflicting information in the protected area and the unprotected area, how we deal with that. We solve it that the unprotected area is overridden, but other people might have other requirements. And we need again to think about the detection of the man-in-the-middle attacks, especially downgrade attacks. And again, the indication and detection for support of new header protection comes here as well in the receiver side. Next. I skipped the requirements for interoperation with legacy clients. Maybe you can go backwards because there's discussions on this. We're probably skipping, sorry, I just skipped the requirements because we don't have time to also go into that down. Are there any comments on the requirements in particular interested? Did I miss something?
Alexi, I think it's pretty comprehensive. Thank you for doing this. The only other thing I can think of is actually regarding legacy ones, UI considerations. With everything else equal, if two alternatives have different UI side effects on legacy clients, that might help us decide.
Yeah.
You know.
Yeah, partly it's in it. If you go back to the sender. Down, two slides down, please. Yeah, here. Partly it's in it in the BS3, but it probably can be enhanced to what you just meant, that general UI considerations.
Yeah, I think it's a slight variation of this, but yeah.
Yeah, that's what I think. Okay, any more comments or requirements missing on something?
This is DKG. So I think this is a great enumeration of requirements. We can nitpick about which things belong exactly in under what section here, but I think you've done a good job of identifying the concerns. I will note that BS3 there is actually about legacy clients, right? So you haven't skipped legacy clients. That in fact BS3 may in fact be the specific question about legacy clients. So right. So we need to keep that in mind.
Yeah, correct. Okay. Any further comments? Otherwise, there's some. The next one, please. So for those of you who want to know more about our implementation and what we intend to do, we just got a mailing list approved for missing elements for decentralized and usable privacy. You find here the information how you can sign up. And we decided to make a non-working group meeting on Thursday evening. It's after all the sessions. There will be an introduction. There will be some researchers from University of Luxembourg speaking about specific topics in the area. And we will give a status update in documents and probably talk about some issues and how we go on further. And there's also a link to the current agenda. Welcome to join there. And we also have some list if you could indicate that you're coming so that we know how many people to expect. Yeah, I think it's my last slide. If there are any questions, feel free to ask them now. Otherwise, Alexei is continuing with the same topic.
All right.
Sorry, this is DKG. One comment about I was hiding. I snuck out. So I've half-written draft that I have a draft email of comments on this that I haven't sent it to the list yet, and I will shortly. But one thing that I want to mention, you talked about the MIME structure issues. I do think that we need to think clearly about the MIME structure issues, both for SMIME and for PGP MIME. But I'm concerned that at least some pieces in the draft seem to impose pretty severe constraints on the payload of the message that feel like they might be starting to expand the scope beyond questions of just header protection. And I think that they're in a section that's, I think it's mainly implementation description of like things that you've done, but I want to make sure that we don't, like, I think that this draft will become unwieldy if it starts to say, by the way, this is only going to work if your message payload happens to have the following structure. Right? I think we can say stuff about how the cryptographic envelope is going to be structured to make sure that this works, but I think it would be good to make sure that we prune out stuff that says you have to have a structure in this way. So I'm just wary of that particular issue, and so I'm happy to work with you to try to make sure that we can get that in shape. But I don't want it to say you can't send arbitrary mail like this. That this will only work for some subset of emails. That strikes me as a potential problem, and so we need to think about how to structure that.
Well, just a short answer to that. This is like the first stuff that I made in pretty short time. And this is probably what happens if you have in mind what you have been implementing, then it's probably coming like this, but for sure, I'll put this for discussion, and it's not meant to be like just what we want there. So it should fit for everybody. Everybody should be happy about it.
Sounds good.
So it's not my intention to enforce anything of our implementation here.
Cool. Well, I'm happy to help. To offer text and edits and stuff. So.
Yeah, feel free to comment on the list, and we'll take it into consideration.
All right. If we're done with that one, then we'll move on to Alexei's header protection draft.
So yeah, to be honest, I didn't think the chart is not updated. We haven't adopted the document. There are still two choices we need to pick from, which is A, the memory hole type approach, or wrapping as in a SMIME document as specified with small tweaks. I think this is more of a call for action and plan of action for, till next IETF. Next slide, please. Right, so this is basically stating the problem, and previous presentation done a very good job and talking about requirements, a specific, disagreeing inner and outer headers, and what exactly you want to put in the outer if the inner is encrypted, do you obfuscate, and all kind of scenarios. Right, and the main reason why we have this problem is because mostly deployed clients, they don't support the text in the current RFC. So something needs to be done. Next slide. Right, and just, ideally, actually, it might be possible requirement. We might want to try to address the problem in the same way for SMIME and OpenPGP. That might not be a strong requirement, but it's nice to have. So the problem with what's in, I think the document is on auth 48. You probably already know the RFC number, but there is ambiguity about whether, if you want to forward a message or if you want to protect header, some clients, wouldn't have a way to distinguish the two. So it would be nice to have a extra field signal in the difference. Right, and from the practical standpoint, even if we pick one of the two mechanisms, we still need to give more recommendations about what should be in the inner header and what should be in the outer header. because this is quite complicated among even the people who try to implement this. I'm not sure we have quite consensus even on this, so I think this would be really helpful to implementers. Next slide. Right, so this is just recap from the draft I wrote and presented last time. There are two choices. One is a wrapping header in an extra, message RFC822. And the other one is just add all the headers together with a content header memory hole approach. So, yeah, we can skip that. So this is my proposal, what we do next. We'll start talking about requirements. So I don't suggest we should publish RFC on requirements, but I think it's very useful to discuss them and agree on the main goals and at least, must have, nice to have, this sort of thing. I suggest between now and Montreal, we try to test. Like I will be able to update my implementation to implement either approach, and I can generate messages. We can try to test and see how they display in legacy clients, and try to see if there are any unusual UI artifacts or error conditions, this sort of things. And maybe we can do something for hackathon on this in Montreal. Then once we have more information, we can have a discussion in the working group, pick one solution. And then the final step is try to write the specific instructions about minimizing unprotected header fields, what the recommendations are. Sounds very easy, but we'll see how it goes. Mm-hmm. I think that's my last slide. Questions?
I'm not sneaking up on so that I can take notes and people name it. Okay. He's not getting up to go to the line.
No. All right.
Go ahead, Krista.
Go ahead, Crystal.
Can you guys hear me?
Yep.
Okay, great. So I'm, in case you don't know me, I'm Krista Bennett. I am the code monkey for the engine on PEP. And I have no religious feelings about this, but I'm probably one of the few people who's actually tried to implement both so far. And I just wanted to give a quick, impression of what the main problem for me was as an implementer. And again, I have no religious feelings here. We didn't actually try to implement generation of memory hole. And this was early on, so the draft was in a kind of funny state, and it's kind of hard to tell what was intended, what wasn't. For memory hole, the problem for us is that you really can't tell implementers what kind of MIME libraries they're going to use, right? We all have different things that we have behind the scenes. And parsing that was a real pain because I had to hack the MIME parser. Whereas to do this wrapping approach, all I really had to do was move something down in a data structure. And it also allowed us to decide what we were going to selectively disclose from that header rather than taking an existing header and removing things from it. And I know that sounds dumb, but it's just conceptually, as an implementer, a lot easier to do the latter approach where you're actually just saying, okay, I'm going to move the message down, I'm going to take out the stuff I need and stick it in the envelope, and off we go. So it's not really anything more than a comment, but if we had some sort of mechanism to distinguish between wrapped messages and unwrapped and forwarded messages, that would be incredibly helpful, because what we see in Thunderbird right now, also because I made a little implementation boo-boo, but that's another story. What we see in Thunderbird right now is that, of course, it does look fairly ugly because people get a forwarded message and they don't know why. So I think that's an important thing to do. But I also, just like I said, from an implementation point of view, manipulating a data structure where you move something from one node in a tree and you wrap it in something else and stick it in another node in the tree makes generation and parsing a lot easier for most people, because most parsers will actually accept this the way it is. So that's all I had to say.
Well, thank you for this. Actually, if there are any considerations for existing APIs on MIME parsing, that's very valuable. So.
Yeah, well, that's all I know so far.
Okay, thank you.
This is DKG. I mean, my main comment is just like, I think that this draft and Bernie's draft seem like they're, there's probably should be one draft ultimately that the working group works on.
Yeah.
So if I'm happy to talk with folks about how we join them, and it doesn't make sense to have two drafts that each specify two different mechanisms. So I hope we can just consolidate into one. And if we can get the charter updated, then maybe we can make it just the one document.
I think the AD's heard that already.
All right. Up next, Daniel on hash signatures.
So this is hash signatures in X509. It's very similar to what Russ did with hash signatures in CMS. Next slide. Well, you've already seen from Russ's presentations previously what hash signatures are about, so I can probably skip this. Stateful, small public keys, large signatures. The use cases that we're looking at are, because it's stateful signatures, you should be using an HSM to do the signing. We're looking at CA certificates and code signing certificates, because mostly for end entities, you might not want to be using an HSM to sign end entity certificates or to do interactive signatures. There was a question on the list whether CMS hash sigs was enough. Our draft also defines XMSS and XMSS-MT algorithm identifiers, so no. Also, RFC 8410 and 8419 define EDDSA in two different drafts, so I guess not. Next. Oh, so I presented actually this, no, this is fine. I presented this remotely in Bangkok, and this is just an update of the changes since then, basically aligning with Russ's draft to sign the full message instead of signing the pre-hash of the message. And there was also just an ASN1 encoding fix. I got some clarification from Jim that we didn't need this extra octet string wrapping of the signature. And I just wanted to make a note about full message signing. We got this from a partner, an HSM partner, basically saying that for large messages, if you're going to sign the full message, a streaming API may be needed because HSM can't store the entire message in memory, and they may not like streaming APIs because it adds session state to their APIs. This might not be so much of a problem for X509 and CMS if the messages are generally small. Maybe more so in X509 if you're starting to add large quantum safe public keys, but even then, I don't think those keys will be so large that HSM can't store them in memory. Next. So really just asking for adoption of this draft and whether there's any comments. I've been aligning it with CMS hash sigs. If it's adopted, we could also possibly align it with RFC 8410 just so that it has similar structure for the, because EDDSA also does full message signing, might make sense to have similar structure between the drafts. So that's it.
Sorry, I'm speaking up again. This is DKG. So can you go back one slide? Yeah. That's fine. Yep. So it would be really useful if the draft says anything about a streaming API to clarify that it is specifically a streaming API for signing only. We have a long history of screwing up streaming APIs for verification, where you start emitting data before you emit the signal that the data is actually secured. So it sounds to me like the reason why you might need the streaming API is specifically for signing only, and so calling that out is distinct use.
Jim says no.
No? Okay, so streaming, so big red flag on streaming APIs for verification.
So the draft doesn't say anything about streaming APIs currently. Whether it needs to, are you saying maybe it does? Let's see what Jim says.
Jim Schott. The reason why you would need a streaming API is if you have a large message to deal with, you have to compute the first hash of that message, and that is going to be the same computation both for signing and verification. The assumption is not that you're streaming the signature itself in and out, but the content you're signing.
So my understanding was that you're saying we need the streaming API for signing because it's an HSM doing the signing, and the HSM, but it's not an HSM doing the verification, I hope, right?
No.
Maybe.
So if the rationale for the streaming is HSMs have limited memory and they can't handle the entire document, that's just signing only requirement.
Agreed.
Okay.
Max Para Cable Labs. So you're talking about streaming API because you assume that you cannot transfer the state back to the client from the HSM.
But that is an option as well, yes.
Because if you do that, then you can just update the state. You don't need streaming API, so there's no real streaming consideration to be done.
I guess that is sort of a streaming API, but it's just...
Yeah, but then you have to think a little bit about the consequences of the client being able to modify the hash state in the middle of the hash operation, and whether that impacts the correctness of the signature.
Quinn Dang at NIST. Since I see there are a lot of people here, I have a question for the group to think about. So when we sign certificates, the key generation time is not a problem here. So why do we have to go to multiple level tree instead of just one tree, one big tree?
So you're just asking why support XMSS-MT and not just XMSS?
Because
or
right now I don't see the need for the multiple level trees for signing certificates. And then you would need a bigger tree. You want more signatures and you want a big tree.
The biggest tree XMSS supports is Scott Fleur. The biggest tree XMSS supports is 20 level. That is 1 million signatures.
Oh, so currently you only specify that small tree for one level tree?
That is the current limit for XMSS. LMS has a limit of 25, so that's 32 million.
Okay. The thing is, but that. So if think about it, because when you have multiple level tree, there is some side channel attack which is applicable to only multiple level tree, but not single level tree. Yeah, I can forward the attack to the mailing list for people too.
My understanding is it's a trade-off there of time to generate the keys, because if you use multiple trees in the HSS, you only have to generate the top tree and one of the branches under it. You don't have to generate all the entire tree of trees until you need to produce the first signature in the next tree.
That's true, but the thing is, the key generation time is not the problem for this kind of applications. And also,
did you hear that number?
No, because that number we could change the parameters to make the tree bigger. That's not like something technically, that we must follow or something.
Yeah, but the numbers that are currently in there are kind of the top end of the numbers that are currently in there are actually kind of stretching the boundaries of what's reasonable for key generation time.
True, I did not remember that number small. But that is a question for people to think of. No, I think you ran some experiment. I think it cost a few minutes, something for IMS. Couple of minutes most.
Okay. For LMSS, on my system, which was multi-core, it took an hour and a half for a 25 level tree.
25.
So that'd be
How many signatures?
32 million signatures.
Is that enough or could be not enough? Okay, could be not enough. Okay.
But even that's a multi-core system that we had, and if you're generating it on an HSM, it could be more restricted.
Okay, with the constraint, with the specification right now, multi-tree seems okay. But with the caveat that I will locate the side channel attack paper and send it to
Yeah,
you.
and another consideration is when you're considering these key generations being an hour, in some cases, it's in the middle of some sort of key ceremony. So, you've got people sitting in a secure room while this happens.
Just grab a beer.
Okay. Okay.
Okay, I have to cut this off because we only have 10 minutes left and we got several more presentations. So we'll do a call for adoption on the list as the next step here.
Thank you.
Thank you. All right. It's not there. You sent them and I posted them. Now I'm confused. Let me hit refresh. Yes, so I'm going to hit refresh. There they are.
Okay. Not that these slides are exciting. Basically, again, we're looking at post-quantum certificates. This basically saying, gee, why do we want them? I think we can pass on that. Hello. Okay, sorry about that. This is about first slide about post-quantum certificates, why we need them. We can pass on that. When we look into post-quantum certificates, there are two major. It's easy enough to say, well, this candidate will basically assign an algorithm identifier and just use it. That's easy, but there are two remaining problems. One is that we may not fully trust these new algorithms, and because of quantum computers, we may not trust the old algorithms either. And so, what do we do? The suggestion we have is to do composite certificate signatures, which actually combine multiple algorithms, so that even we don't trust any one of them, we can trust that not all of them will be broken. The other problem that we do not address in our current draft is backwards compatibility. What we plan to do is actually propose multiple parallel certificates, one with the old RSA or ECDSA certificates algorithms, and one with these new post-quantum algorithms, which would most likely include the composite signatures. Thank you. Next slide. What are basically our idea is basically a certificate has public keys, has signatures, has algorithm identifiers, and so what we simply do is just combine them into a larger algorithm, which is treated as a single signature algorithm. So a public key would basically be a sequence of the various public keys for the various algorithms. The signature would be just a sequence of the various signatures all signing the exact same data, and the algorithm ID would be the standard ID, a arbitrary ID, followed by a sequence of the various component identifiers. And so with doing that, we can basically, all the certificate looks basically like a normal certificate, just with a different newer algorithm. And we also would need to take a look at how to make sure that the signer and the receiver can all understand this newer algorithm. But we're going to have to address that for any sort of new algorithm. The advantages is simplicity. It's actually relatively, it's no change at all to the certificate architecture. We're just changing the algorithm. Nice thing about this is that signature algorithms can be used outside of certificates. For example, if we're assigning a TLS transcript, we can use this new composite algorithm to actually do a signature, which which can be verified, and so we'd actually have the hybrid strength or composite strength on extending down into the TLS level. And I wrote it's IPR free. I found out recently that Max Paula has some IPR, but apparently he has very he has very easy terms. And this
He's
is
at the mic, so let's hear what he has to
okay.
say.
Yes. Oh, yes, and we hope to be working with you.
Okay, so I had a question for you, but I guess the question was because when I read the draft that you posted, actually, which Ross pointed it to me, I was really surprised about all the similarities of the idea that I shared with some of your authors, and I was not involved. I was a little upset about that, but I really want the idea to move forward. As a disclosure for the IP, so we apply for the IPR before we disclose the idea to you, as usual, because we want to protect the idea and make sure that everybody can actually work on that. Since IP is becoming a little problem, especially with standard bodies. So there, we published the IPR disclosure, royalty-free with a reciprocity. In the slides that, I don't know, probably we're not going to be able to see that for my presentation, but there's the link to the IPR declaration. So if you want to take a look at that, it's all there. Yeah, that's it.
Mike Elmsworth, Entrust Data Card.
Closer
I'm
to the mic.
Mike Elmsworth, Entrust Data Card.
Turn it up.
Hello.
Yeah, there you go.
So I'm the primary editor on this draft. So Max, we had reached out to you in August, and I think we just crossed because we wanted to get involved in what you were writing, but then we didn't get involved in your group. So yeah, I would love to be involved with you. I think we should really merge. I think we sort of developed the idea independently. Maybe your language came in. Yeah, I would love to be involved. That wasn't meant to be a slight. We had tried to reach out in August and it just didn't work. As for IP, I think we're all on the same board. We want this to be completely free, open, public. Yeah, we're not. Yes, I think this is great. Let's get together.
Okay, I think we'll wait for a merged draft before we do a call for adoption. Thank you. Next is Hendrik. And we're down to 5 minutes, so I'm doubting we're going to get both presentations in.
Okay, welcome everybody. I will hurry up with my slides. So I'm going to present a work we did at Siemens on profiling CMP for industrial use cases. Can you go to the next slide? So currently CMP is quite in practical use for a number of years. So on the one hand, CA vendors use it for RA to CA communication, and also in the mobile network backbone, CMP is in use for over 10 years now, and in the train control environment, CMP is also used for certificate management. And can you go to the next slide, please? And we see quite a lot of features in CMP, too much features than are used or needed really, but we see quite a lot of features that are very good in industrial machine-to-machine environments, like self-contained messages, support for end-to-end security over a number of hops, or out-of-band transport mechanisms, or very small polling messages and in-band confirmation, things like that. And that's why we see that is quite good use for industrial use cases. Can you go to the next slide, please? These are the typical use cases everyone knows, like initialize, update, revoke, but also some further use cases that may be implemented with CMP, but what may be more important, CMP is quite easily extendable with a general message concept. So if someone, for example, wants to transport an 8366 voucher, then this can be easily implemented with a general message. Okay. From our experience from our company, we see not only the mobile network and rail communication use cases, but we also see use cases, for example, in the e-charging environment. There is a protocol called OCPP, Open Charge Point Protocol, that is from the standardization body used to be the only protocol the charge point is using, and CMP, as it is self-contained, can easily be transported using the container messages from OCPP, but also for rolling stock equipment, which has not always connectivity to backend. This self-contained messages can be transported in a store and forward mechanism. So we see quite a number of use cases in the backup of the slides. There is a bit more details to these use cases. So for everyone who is interested in looking that up and reviewing it, you're welcome. The slides are online. Okay, so profiling from our point of view is essential to get the CMP, the quite baroque feature-rich CMP, stripped down to the needed functionality so that it is easy to implement and interoperability is possible. But we not only see the end entity to PKI communication that is typically addressed in certificate management protocols, but especially in industrial environments, we see engineering tooling management tools, asset inventory, monitoring systems, network access control. So we think also the lab between the LRA, RA, CA would be good to do some standardization work on that part, because we see in the future more and more interoperable needs for multi-vendor environments there too. And CMP offers, from our point of view, the needed functionality, but it needs to be specified in more detail. Okay. Yeah, so what is to be done? This is an example. Maybe the formatting is a bit broken, but this would be an example how this such initial enrollment could work. So this is similar what is also implemented in the 5G network and the ETCS. So the end entity is signing the request, forwarded it to LRA or RA, one of them doing the authorization on the request and attaching its RA signature and forwarding it to the CA. And then the CA can verify not only the proof of possession, but also the authorization of the RA and issue the certificate and return the certificate back transparently through the hops to the end entity. And we have a confirmation message exchange where the messages are really small to ensure that the enrollment worked properly. So this can be exchanged, but not necessarily needs to be exchanged. This can also be skipped if needed. Yeah, so what is our request or question? Would this work be interesting to the working group as updating, let's say, CMP, RFC, with some more concrete profiling on industrial use cases? And of course, we are happy to get use cases, learn about use cases from other companies to see whether they are covered in the current draft or figure out how they could be addressed with transactions. So I'm welcome to get feedback, whatever you have.
So this is currently not in the charter, and this is work that if people are interested in, we'd have to recharter to do. So I'd like to hear whether people support this or not.
Max Pollack, Cable Labs. We actually have some use cases in the medical industry and some other parts that actually are struggling with coming up with a profile for CNP that they understand. I think that this work can be really important for those environments, so I would support this. And the other use case that I have is a presentation that we gave in the EMO working group about provisioning credentials through EAP, and CNP is one of the use cases that we would like to support.
Okay, thank you, Max.
Hi, Sean Turner. I think I sent some of this to the mailing list already. There's other groups that are in the IETF, like ACE. They're looking at exactly this thing for industrial control stuff for IoT type devices. So it seems like if we adopt this, we're stepping on toes. You're going to have to do some kind of coordination to figure out who's going to do what to whom. It would be weird. I mean, the PKI community screwed up and had CNP, CMC, blah, 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 right? So we can pick one. So as an infrastructure, people that I support, they're like, I got to do 4 things, right, to get certs in. And that's not great. We maybe should try to not burden the industrial control world with the same problems that the web had. So it'd be good to see if we could get some kind of coordination to figure out what ones to use.
Okay, thank you.
Okay, so at this point, we're going to continue discussing on the list. We're already run over our time by 6 minutes. So Max, I'm sorry, you're not going to get to talk. And you're
There's a comment about this.
really fast. So thank you very much. Enjoy your lunch, and let's continue this discussion on the list. And Max, talk about your draft on the list, please. Okay, thank you. Thank you. Sorry?
I believe it's Lamb's chair.
It's Lamb's chair.
Yeah.